All right, in this lesson, we're going to look at power series. We haven't called them power series yet, but we have looked at a Taylor polynomial. And if we just let that polynomial keep on going, then it'll be called a power series because the series has infinite terms added together. And now we have this infinite polynomial that has infinite terms. Before we start, let's review that this is a geometric series and it converges because the common ratio is between 1 and -1. And what we're going to look at new today is this series, which has, it looks similar, or we could think of it as being similar to the geometric series because it's exponential. And if the geometric series requires that the ratio is between 1 and -1, well, then this series will converge if x is between 1 and -1. All right, and this is the type of question we'll be seeing. We want to find out this series will converge if we have the right value in here. So I just have to figure out what values, for whatever values of x this converges, it only converge for that interval. So to do that, we're going to do the ratio test. And we need to have the limit as n goes to infinity. We'll take this term and replace the n with an n plus 1 divided by the given term. And we also want the absolute value. So if we rewrite this as 3x minus 2 to the n, x minus 2, because there's a 1 there, so by multiplying this we'd have n plus 1, which would give us that. And then we can do this because they cancel, they equal 1. So the limit, there's no more n. That means it doesn't matter what n does, as n goes to infinity, the limit will be this. So the limit is x minus 2, absolute value of x minus 2, and the ratio test requires that the ratio, or the limit of the ratio, is less than 1 for it to converge. For the series to converge, we need the ratio, the limit of the ratio, less than 1. And when an absolute value is less than 1, then we can rewrite it as x minus 2 has to be between -1 and 1. And we'll add 2 to both sides. And we get, or add 2 to every part, and we'll get x converges between 1 and 3. The series converges between 1 and 3. And then we have to look at the endpoints. Will the series converge when x equals 1? So this only says that it's strictly less than, but what's going to happen when x equals 1? So then we check the endpoints. And we check when when x equals 1, we have so here we have 3, negative 1 to the n, and this we could say is going to diverge because this is not between 1 and negative 1. So the series diverges. We could also say that it's alternating with the sequence not decreasing, so then it'll diverge. And then we'll check 3. Three times. That's just going to be 1 to the n. 1 to the n is just 1, so this will diverge. We're just adding 3 infinitely. All right. So the endpoints, the series does not converge at the endpoint. So now we say that the interval of convergence is from 1 to 3, not including 1 and 3. We also have some vocabulary, the radius of convergence. So we could say that the series is centered at 2, and it will converge up to 3 and down to 1. And then this is called the radius of convergence. The radius is 1. It's the radius of convergence. All right, and pause the video and try that one. So we'll do the ratio test. The limit as n goes to infinity. We'll copy all of that with an n plus 1. Then we have to multiply by the reciprocal of the original term, absolute value, and the absolute value will take care of the, this should be an n, absolute value will take care of the negative. We don't have to worry about the negative anymore. And then let's break up these exponentials. So we can cancel, and we're left with x plus 1 over 2. As n goes to infinity, x just does whatever it wants to do. So the n doesn't affect the x. Everything with an n is gone. So now we can just say that the limit is x plus 1 over 2, absolute value. We want that to be less than 1 for the series to converge. So now we have negative 1 is less than x plus 1 over 2 is less than 1. Let's multiply by 2. Subtract 1. So there's the interval of convergence, negative 3 to 1, but we should check the endpoints. At x equals negative 3, negative 3 plus 1 to the n, 2 to the n, and we'll also check 1. This will be 1 plus 1 to the n. So that's the original sequence, and we just replace the x. Here we'll have negative 2, and we could take a negative 1 out of there, so we would have negative 1 to the n, negative 1 to the n, 2 to the n. So those cancel. These will be a positive 1, and we just have this adding 1 over and over, so that diverges. And with this one, we'll have a 2 to the n. Those will cancel, and we'll also have divergence. So we can say that the interval is negative 3 to 1, and the radius, if it's centered at 1, no, centered at negative 1. So if we have 1, 0, negative 1, negative 2, negative 3, then we must be centered at negative 1 with a radius of 2. Radius of convergence. All right, pause the video and try that one. Just replace all the n's with an n plus 1, then we'll multiply by the reciprocal. We don't need the negative anymore because we're doing absolute value, and we'll separate the exponential here. We have n plus 1, n plus 2, And down here, n plus 2, n plus 3. And cancel that. Cancel n plus 2. And as n goes to infinity, we would get infinity over infinity, but then we could do L'Hopital's rule, and we would just have the limit being absolute value of x. We want that to be less than 1, so now we have that interval, and then we'll check the endpoints, and we're going to check -1. All right, and here we could put those together and be a positive, so we just have 1 over n plus 1, n plus 2. And it looks like it's going to converge because the denominator has a power of 2, and we could just do direct comparison and say that this is less than this. So here are the terms of a convergent series, and this is less than those terms, so we know that this series converges. Over here, it'll be the same thing, but it's alternating. This we don't need, that's just a 1. And if a series converges on its own, it's still going to converge when it's alternating. So we'd say that this is absolutely convergent. And that means we have convergence at the endpoints, and then we would say the interval of convergence is from -1 to 1, but now we use brackets, and we can say that the radius of convergence is 1 because it's converging all the way from -1 to 1, so it's centered at 0, and the radius is 1. All right, pause the video and try that one. So let's distribute the 2. We'd have 2n plus 2, so we could write it as x to the 2n times x squared. And Here we have 2n factorial. This will be 2n plus 2 factorial, which would be 2n plus 2, 2n plus 1 times 2n all the way down to 1, and then times x to the 2n. So 2n down to 1 is 2n factorial, and this will cancel. We also have x to the 2n, x to the 2n, and we're left with n in the denominator. And now the n hasn't canceled out, and as n goes to infinity, the denominator goes to infinity, and that means this goes to 0. And that means that this series will converge for all x, and its interval of convergence is all real numbers. We could say negative infinity to infinity. And it turns out that the series we just looked at is the series, the power series of cosines. So this will be exactly the same as cosine. If you graph this, it'll be the same as cosine. And just 2 more examples, quick examples. Let's just see what we can do with derivatives, and we're just going to follow all the same rules that we do with functions. Here we have a series, so we can say that the derivative, let's write out what the function is. And when we put a 1 in, we're going to have a 1 there. We're going to square it so it's positive. Put a 1 there and we'll have x minus 5. Put a 1 there, and we'll end up with a 5. So x minus 5 over 5. Let's put a 2 here, so we get a negative. Put a 2 here, and we're going to have x minus 5 squared. And then put a 2, we get 50 in the denominator. We'll have x minus 5 cubed, and that'll be 375. And when we do the derivative, we could take the derivative of each of these, but we can also just use the derivative, take the derivative with this. And all we have to focus on is the x. And we're going to, this is not, when we write it out, this is not an exponential. We don't do the derivative like an exponential. We're going to do the derivative just with the power rule. It would be like doing the derivative of each term. So let's multiply by n. We'll have negative 1 n x minus 5 to the n minus 1 over So that's how we do the derivative. And then the antiderivative is just going to be the power rule so we will add 1 to the exponent, and divide by that. And if we did the antiderivative of this, it would be x squared. So if I put a 1 in here, we're going to get the second power there also. So we can just use the power rule on those. And find the derivative and antiderivative of this. Pause the video. So there's the derivative, cancel the ends, and the antiderivative is going to be add 1 to the exponent and divide by that. And that's the end of this lesson.